Hello, boys and girls. Today we're going to work on lesson 2.3, which involves place value in whole numbers. We do have some vocabulary for this lesson. The first vocabulary word is counting number. And when we talk about a counting number, that would be all of the numbers except 0, because when we count objects, we don't start with 0. So counting numbers is your first one. Whole numbers is your second. All numbers and 0. So that's what would be included with whole numbers. Okay, a digit is equal to a number. So I just put these on here because you'll hear these words in class. I just want you to be familiar with the term. You don't necessarily have to write it down if you don't want to. But a digit equals a number, and place equals the spot that the digit is in. For example, if it is in the ones place or the tens place. Now, what I want you to do is I want you to look at the numbers that I've given you here on the screen. I want you to write the largest number using the digits 0, 3, 9, and 7. And you can see that I have started my number with 9 because I want to write the largest number. I'll give you just a second. Did you come up with 9,730? If you did, great job. Now, when I look at that number, which digit is in the ones place? Did you say 0? If you did, that would be correct. Which digit is in the tens place? Hopefully you are thinking 3 because that is also correct. The hundreds place would be the 7. And the thousands place would be our 9. Now, using those same digits, what is the smallest number that you can come up with, not starting with 0? Did you come up with 3,079? Good job. Okay, looking at those digits now, did the values of the digits change when we moved them from one place to another? If you answered yes, you would also be correct. Okay, we are going to take a look at a place value chart. And if you look at the left side, it says number. And then we go all the way from left to right, from the 100 millions all the way to the ones column. Okay, that would be our place value. So what I did on the left is I wrote down 4 numbers, and I'm showing you how we would place them in a chart in the correct order. So usually when you write a number, you usually write it from left to right. But if you're going to put it in a chart like this, I would start on the right side with your last digit and put it in the very last column there in the ones and go backwards. And that way you can kind of figure out where those digits will be placed in the place value chart. So when we look at 853, we start in the ones column and place the 3. The tens column would be the 5, and the hundreds column would be the 8. Okay? We go down to the second number where I have 1,794. If I place the 4 in the ones column first, and then the 9 working my way backwards, I end up placing the 1 in the thousands column and the 7 in the hundreds column. Okay, this is one way to organize your numbers, because sometimes when you have a number that has zeros in it, it will force you to place those zeros in the correct spot on the place value chart. So let's jump down to the last number, 103695. If we start with the 5 and put the 5 in the ones column and the 9 in the tens, the 6 in the hundreds, the 3 in the thousands, and then we have that 0 we're going to place in the 10,000s, and the 1 goes in the 100,000s. So hopefully that makes sense to you. You're basically organizing those numbers and placing them in their correct spot on the place value chart. Now I'm going to talk about expanded notation. We've had a couple of problems in math boxes where they have asked you to put numbers in expanded notation, and some of you didn't know what that was, and some of you may have just forgotten. But I've got 3 examples here. 853, and basically what you're going to do is write down the value of each of those digits, and then you're adding them together. So if we look at 853, the 8 is worth 800, the 5 is worth 50, and the 3 is worth 3. So you can see my equation says 800 plus 50 plus 3. That is expanded notation. Let's look at the second one. We have 4, 5, 7. That 4 is worth 400, the 5 is worth 50, and the 7 is worth 1. So we have 400 plus 50 plus 7. Let's look at the third one. We have 1,253, and the 1 is worth 1,000, the 2 is worth 200, the 5 is worth 50, and the 3 is worth 3. So again, my equation would be 1,000 plus 200 plus 50 plus 3. So that, boys and girls, is expanded notation. So let's recap a little bit. I'm still going to kind of use expanded notation with this, and you'll see what I'm talking about in a second. We're just not going to have the equation part. So if we look at the number 975, the 9 is worth how much? 900. The 7 is worth 70, and the 5 would be worth 5. So we fill those in. That is what we would write for that problem if that were given to us to complete. So let's take a look at this number. We have 37,052. So the 3 would be worth 30,000. The 7, 7,000. The 0 is actually worth 0. 5 is worth 50. And last but not least, the 2 is worth 2. Okay, you will have some larger numbers that you will have to complete in a class. Okay, so our summary today. We talked about counting versus whole numbers. Our counting numbers are all the numbers except 0, because when we count, we don't start with 0. Our whole numbers include all of the numbers and 0. We talked about place value and how to put numbers or digits in the correct places on a place value chart and what their value is. And we touched on expanded notation, where we kind of take apart those numbers and add their values together to get the number. All right, thank you for watching.